To Tonu Science. In this video, we'll learn the problems in acoustics. First problem: a sound wave has a frequency of 200 Hz and a speed of 400 meters second power minus 1 in a medium. Find the wavelength of the sound wave. So, your frequency given 200 Hz and the speed given 400 ms per minus 1. The frequency taken as n and the speed taken in v. Find the wavelength. So then we have to find the wavelength lambda. Solution: we know the relation among these n v lambda. V is equal to n lambda. According to the question, we are going to find the wavelength. Lambda is equal to v by n. Lambda is equal to, where v is equal to 400, then frequency is equal to 200. If we cancel this, we'll get 2. Unit of wavelength is meter. So final answer, that wavelength of sound wave is 2 meter. Second problem: a thunder of cloud is heard 9.8 seconds later than the flash of lightning. If the speed of sound in air is 330 meters second power minus 1, what will be the height of the cloud? So here given time t and one more numerical data, speed of sound, that is v. We have to find the height of the cloud. So first lightning going to be seen, then we'll hear the thunder, because speed of light is very much greater than speed of sound. So first we'll see the lightning, then next we'll hear the thunder sound. Okay, now we are going to find out the height of the cloud. So this is a cloud, this is a ground. This take it as height h. Now time to travel that thunder sound is 9.8 second. Then velocity of the sound is 330 ms power minus 1. So we have to find the height of the cloud from the ground. Basic formula for speed: distance by time. So speed is equal to distance by time. You can write s or v. So v is equal to distance by time. This distance we are going to take it as height. According to that problem, we are going to find out the height. So to find the height, h will be one side, then velocity or speed into time vt. Now h is equal to v, the given 330, speed of sound, into time. So time they given 9.8. So if you multiply 3234 meter, this is height of the cloud from the ground. Question number 3. A person who is sitting at a distance of 400 meters from a source of sound is listening to a sound of 600 Hz. Find the time period between successive compressions from the source. So this is the source, this is the observer. The distance between the source and the observer is 400 meters. The frequency of the sound source is n 600 Hz. Find the time period between the successive compressions. So the time period for the successive compressions is nothing but time period of one oscillation. This is one compression, this is another compression. So the time period for this successive compression is nothing but time period for one wave. So time period is nothing but reciprocal of frequency, t is equal to 1 by n. Then t is equal to 1 by, where n value 600 Hz, 600, then t is equal to, if we divide this, we'll get 0.0017 seconds. So unit of time is second. Question number 4. An ultrasonic wave is sent from a ship towards the bottom of the sea. It is found that the time interval between the transmission and reception of the wave is 1.6 seconds. What is the depth of the sea? If the velocity of sound in the sea water is 1400 meters second power minus 1. Consider this is the ship. So from the ship, we are going to send the ultrasonic wave. So from the transmitter, we are going to send the ultrasonic wave. This is seabed. It's the bottom of the sea. After the incident of this ultrasonic wave, it is reflected back to the receiver. Or the time interval between the transmission and reception is given 1.6 seconds. So t is equal to 1.6 seconds. The velocity of this is here water is there. We know that the velocity of sound in the sea water v is equal to 1400 ms power minus 1. So now we have to find that depth of the sea. So depth of the sea is nothing but height of the ship from the seabed or bottom of the sea. So depth of the sea. Depth of the sea we can take it as h. We know that basic formula for velocity v is equal to distance by time. So your distance for transmission and reception. For transmission 1h and reception 1h. So the distance is 2h. V is equal to 2h divided by time. Now we need height. So h, depth of the sea. So h is equal to v. This time we can simply write it as t divided by 2. So h is equal to velocity of the sound wave in the sea water given as 1400 into time the given 1.6 second, so divided by 2, then h is equal to, if you divide this 2, 7 2s are 1400, so 700 into 1.6, then h is equal to 700 into 1.6, and if you multiply these two you'll get 1120 unit of height here meter. So if you want to say in the kilometer, divide by 1000, so h is equal to 1.12 kilometer. This is bottom of the sea. Question number 5. A man is standing between two vertical walls 680 meter apart. So a man is standing between two vertical wall. This is a vertical wall, this is another one vertical wall, 680 meter apart. So the distance between these two vertical walls is 680 meter. He claps his hands and he has two distinct echoes after 0.9 second and 1.1 second respectively. What is the speed of sound in air? So here medium is air. First echo sound heard in the time interval of 0.9 second. Next echo sound heard in the time interval 1.1 second. So this 0.9 you can take as t1, this 1.1 second you can take as t2. Now we have to find the what is the speed of sound in the air. Total time for echo sound t is equal t1 plus t2. T is equal t1 value 0.9 plus t2 value 1.1. So total time is 2 seconds. The distance given here between the two vertical walls is 680 meter. Now we have to find the speed of sound wave in the air. We know that speed of sound formula v is equal to distance by time. So v is equal to distance by time. Here distance becomes for echo one distance for transmission, another one distance for reception. So that here 2 into distance. So v is equal to, your distance between the two vertical wall is 680 divided by time, his total time is 2 seconds. So 2 going to be cancelled, then v is equal to 680 unit of speed meter second power minus 1. This is the answer. Question number 6. Two observers are stationed in two boats 4.5 km apart. A sound signal sent by one underwater reaches the other after 3 seconds. What is the speed of sound in the water? This is one boat, this is another one boat. So one observer, another observer. The distance between these two observer is 4.5 km. Now one observer going to send the signal underwater to reach the second observer, so that sound heard by the second observer after 3 seconds So the time period is 3 seconds. Now what is the speed of sound in water? So in water we have to find the speed of sound. So speed of sound formula, we know that v is equal to distance by time, where distance is 4.5 kilometer. This 4.5 kilometer we can convert into meter by multiplying the 1000. So distance d 4.5 kilo. So kilo means 1000 divided by time. Time is 3 seconds. Now v is equal to, if we cancel this, 1.5, 3s are 4.5. So 1.5 into 1000 is 1500 meter second power minus 1. This is the velocity of or speed of sound in water. A strong sound signal is sent from a ship towards the bottom of the sea. It is received back after 1 second. What is the depth of the sea given that the speed of sound in water 1450 meters second power minus 1. So this one considered as a ship. From the ship, strong sound signal sent to the bottom of the sea. This is bottom of sea. After 1 second, the sound reflected back to the ship. Now what is the depth of the sea? So we have to find out depth d, we have to find out. Given velocity of sound in water or speed of sound in water, v is equal to 1450 meter second power minus 1. Solution, we know that speed of sound v is equal to distance by time. Here distance is twice, because one for transmission, another one for reception. Now we are going to find out depth. So depth in the sense here distance. So simply you can take it as d, the distance as d. The d represents distance. According to this problem, d represents depth. So v, this time will come here. Simply you can take as t. Then d, 2 will come to denominator. This is depth. So speed of sound in water 1450 into time is 1 second. 1 divided by 2 is equal to depth. If we simplify this, we will get 725. So depth of the sea is 725 meter is equal to depth. Unit of depth.
Thank you, students.